Assalamu alaikum. Hello guys. Now I'll be doing the third case of the student T distribution, and the third case of T distribution is the testing hypothesis about the difference of mean of two normal population when the variances or standard deviation are not equal but unknown. So this is the main difference between the second test and the third test. Here we are having the two sample variance population variance as equal, and here we are having the two variances are not equal. So for that case I'll be referring to the same exercise and question number 18.21 A part. It is starting from 18.21 20. You can do the practice on 20 and rest of the question I have told you in the last slides. So here I'm doing the practice for this question particular on the 18.21 A part. First of all, read the question carefully, because until you read the question carefully, you cannot do question correctly. The highest of the 6 randomly selected sailors are in inches: 63, 65, 68, 69, 71 and 72. So in the first sample we are having 6 sailors, and they are having the height in this question, and those of the 10 randomly selected soldiers. Now there are soldiers. The difference between sailors and soldiers. The 6 sailors have been taken for their height, and now the 10 soldiers have been taken for their heights, and their heights are in inches. That is 61, 62, 65, 66, 69, 69 again, 70, 71, 72 and 73. Now the question is this: discuss the light of this data that the soldiers are on the average taller than the sailor. Assume that the heights are normally distributed. So I think if you read the question very much carefully, so you can take it a good start, because the first step we will be doing would be the setting the hypothesis statement. So that's why I'll be going to the third case. So this is our third case, and yes, this is our third case. I'll be just taking this as copy and taking it to the next page, because I want to save one table here. So here I am having the question about the problem number is 18.21 A part. So 18.21 A part I am doing here, and we are having 2 samples, 6 of sailors and 10 of the soldiers, and the question is we have to find out that the soldiers on the average taller than the sailors. So our first sample would be the sailor, and the second sample would be the soldier. So it is telling us that the second sample would be having more than the sailors. So mu1 is less than the mu2. That would be our null hypothesis, alternative hypothesis for the first case. So first of all, I would be setting the statement. There is no difference between the heights of sailors and soldiers. So this is our null hypothesis, and the alternative hypothesis saying that the soldiers' heights are more than the sailors. So mu2 would be the greater than mu1. So I would be having such kind of I'm just eliminating this one, and here I am putting the sign of like that. So this is our null alternative hypothesis, that the mu2 is more than the mu1, or mu1 is less than the mu2. So that would be theme I would be taking to the end. So for this kind of hypothesis, let me explain this hypothesis, alternative hypothesis, in descriptive form as well. The soldiers heights are, yes, soldiers are taller than the sailors. So this is our null alternate hypothesis. The test would be obviously on 5%. I'll be selecting this 5%. And now, guys, the formula is being different, little bit changed, because there is a condition of having unequal variance. When the unequal population is having unequal variance, then the formula would be having like this. It is very different formula from equal variance kind of formula I have solved in the last question. So here is no some kind of pool variance. There is a two different sample variances used in the formula. There is S1 square first. The numerator remains the same. X1 bar minus x2 bar minus mu1 minus mu2. And in the denominator we are having S1 square. S1 square means that the sample variance for the first sample, and divided by N1, and S2 square, that is second sample variance, divided by the N2. But here the critical thing is that we have to calculate the degree of freedom. That is a little bit tricky and difficult to be remembering, but you have to remember this formula. This formula will be giving us the degree of freedom, on the basis of which we will be looking the value from the T table. So this formula should be learned by you, and it is explained like that. It is the ratio where we have given the ratio of variance to the sample size plus the second variance to the sample size, and taking the whole of a square, divided by this ratio of variance to observation squared is being further divided by the N1 minus 1 degree of freedom, plus the second ratio of the variance divided by sorry, it is not N1, it is N2. Let me correct it. This is N2. Okay. The second variance ratio of the variance to the number of observation is squared, divided by the N2 minus N1. So guys, in the next phase I'll be selecting the critical region. So here the degree of freedom is not N1. Here the degree of freedom is V. V is this. This is the degree of freedom. We have to calculate it to find out the formula. And again, this test is not two-tailed test, so I would be because it is showing the less than sign, so I would be taking the value on the left side rather than on the right side. So here I have changed all the required information. Now we are having critical region less than the minus T alpha with V degree of freedom. V degree of freedom at 0.05, that is 0.05. Let me change this here again. So it is 0.05 with V degree of freedom. We will be calculating this V later on. So right now I am having just changing the formula according to my requirement. So this is alpha 0.05 with V degree of freedom. Now first of all we have to calculate this V we have to find out the critical region, and after that we will be solving this kind of question. So this formula will be dealt in, and with this degree of freedom. So for your convenience, I have already calculated the two samples mean and standard deviation. In this Excel sheet, I have already done for the first sample mean and standard deviation and the variance, and for second sample I have calculated the mean, standard deviation and the variance. Obviously variance is the square of the standard deviation. So anyhow, by calculating, because you know the procedure of calculating the mean and the variance, that's why I'm leaving it for you. So first of all, we have to calculate this degree of freedom to have the critical value, critical region value. So I have already done it for you. So by solving all these terms, here I am having the value of degree of freedom as 12, because I have put all the values, required values in the formula. For this variance, I have calculated 12. You know how to calculate the variance, and this n1 is 6, then the second variance is 17.00 something, but I have put it there 17, divided by n2 is 10, and the rest of the values are put in the formula accordingly, and finally we get the value of 12.21, which is equivalent to the 12, because T table doesn't take the ratio value. So that's why I have taken the absolute value closer to the 12. So degree of freedom is 12, and the value of alpha is 0.05. By looking the table 0.05 and having the value of degree of freedom 12, we will be getting the critical value of 1.782. So that value would be equal to 1.782. Actually this would be in negative side, so that's why I am putting the negative sign. So minus 1.782 would be the value of this T alpha 0.05 divided by with the degree of freedom of V on the negative side, minus 1.782. Now we have to calculate the T ratio. As we know that we are having the means, we are having the variances values. So by putting all those values in the formula, we get the value of 0.28 in negative. Guys, x1 bar minus x2 bar. X1 bar was the mean of the first sample, x2 bar was the mean of the second sample, that is 67.5, and mu1 minus mu2 according to our null hypothesis, that becomes 0, because null hypothesis says that there is no difference between the heights of the sailor and soldiers. So if I put in this in the formula, that would become 0. So by solving all this, our normal value is minus 0.28, and our critical value is minus 1.782. So it's quite visible and clear that the minus 0.28 is far less than the minus 1.782. It lies in the critical region. So there I will write the same conclusion, since the calculated value of T is less than the critical value, and therefore we reject null hypothesis. And what is null hypothesis? That is the two means are same, so it is rejected hence the height of soldiers, I'm sorry, I'm again put the wrong, okay, height of the soldiers are found taller than the sailors. So this is our actually the conclusion. So this is how you can check the difference between the two population with the population variances are not same. You can check the whole thing. So the final case would be we have done so far 3 cases of the t distribution. Now we will be doing the final case of the t distribution in the next video. Thank you very much. Keep safe, and keep looking this video very carefully. If you don't understand anything, just pause it, rewind it, or if any serious problem, you can call me at my phone number. Thank you very much.